Hi students, welcome to Investigation 4.4 using similar triangles and direct measurements. Um, Basically it's word problem day. I hope you're watching this video because I wasn't recording when I did the first one. So I really hope you're watching this. Alright, so what do they mean by indirect measurements? Alright, you need to measure something really tall. Alright, like the Statue of Liberty. But it's really hard to do that. There's issues like a tape measure that's big enough, a ladder that's big enough. When you're that high up, the wind starts to get very dangerous. So you'd rather not do that. But here's the thing, if you can't measure the Statue of Liberty, all you have left is like her shadow. Statue of Liberty is a she, by the way. That is a lady. So let's say it's a sunny day and I told you her shadow is 50 feet. Awesome. So you've got a height and you have a width, and then you can connect those two dots and make a little triangle, right? Why do you care? Because if you make a similar triangle, you can indirectly measure the Statue of Liberty. All right. So what do I mean by that? Let's say you take a stick and it's yours, so you know it's 30 feet, right? You know it's 30 feet. And the sun is still out, so it must cast a shadow. And we measure it, it's 5 feet. 5 feet is super easy. We could do that with a tape measure. And then we connect those two things and we make a triangle to make our life easy, right? And guess what? You've got two shapes now, two triangles. You've got a height, you've got a width, you've got a height, you've got a width, and you need to find the height. Well, guess what? You did that just the other day. You found all kinds of things. Scale factor ratio, you did it all. The only difference is that I drew a picture in the background and gave you a story. All right. So let's take a look here. I need to go from 30 feet to X feet. Let's make that a different color. I need to find the height. All right. So another way to find that out is to see how much bigger is this triangle. I can do that by taking a look at 5 feet going to 50. How much bigger is 50 than 5? You're right. It is 10 times bigger. Those of you who it's not obvious and you really like your calculator, here's how people did it in their mind. They did the scale factor is where you start in the bottom and then where you end on the top. Some of you are, I meant to put end. Some of you are not sure how to put this in a calculator, so I'm going to show you right now so we can put this to rest. Let me make sure this is cooperating. So that would be 50 over 5. 50 over 5, what does that look like? 50 over 5. 50 divided by 5. It even kind of looks like it in the calculator if you notice. And then push enter, and that's 10. Awesome. And you could have checked and said, oh, that is 10 times bigger, right? Cool. We now know this triangle on the left is 10 times bigger. So that means 30 times 10, let's see, 30 times 10 is going to give us our x, right? I'll give you some time for the calculator. Should be 300. And we're going to say feet. Whatever we're measuring with over here, unless somebody says otherwise, we're going to assume we're still measuring in feet. Because why would I measure the shadow in feet and then be like, let's use miles, right? Let's just keep it the same. All right. Let's see here. Let's move on to the next problem. This is basically what we just did, except like the ratio version. We'll show ratios eventually. So, A says a tree. Let's use a cubes method. Let's box any main words. Cast a 25-foot, it's a number, shadow. Let's make sure they drew this picture right. Sometimes I won't give you the picture, so let's fact check them, make sure they're doing it. They drew a little tree, and it's casting a shadow, and that means the sun's probably over here, right? Cool. And then they said, oh, let's just connect the dots so that we have a triangle. Cool. At the same time, a 6-foot stick casts, so like 6 foot, that's a number, and it's a stick, casts a shadow that's 4.5 feet long. All right, so we drew the stick, and it's casting a shadow. The sun's still there. And let's connect the dots so that we have a triangle to compare to, right? We're going to indirectly measure this tree, so I'm not going to climb a tree. Like, this is something you could do. You could measure a tree's shadow. And you could even use like a ruler to do this if you'd like. You can do this outside yourself right now if you'd like. Don't actually. The sub's not going to let you. But if you really wanted to, we could do this experiment. And it'll work. So let's take a look. Seems like they drew it correctly. What does it want us to find? How tall is the tree? Awesome. So let's do scale factor again. If we want to go from 6 to the height, that means I want to go from 4.5 to 25. This one's not as easy visually, right? I need to go from where I start to where I end. I need to divide some stuff to find the scale factor. So let's see. 25 divided by 4.5 should give me the scale factor. 25 divided by 4.5, the scale factor, 5.555556. All right, I'm going to round to the second decimal place for you, but don't clear the calculator, okay? 5.56. Those of you wondering why I made the equal sign look like that, this is my about sign. That tells people I rounded. So I did not clear my calculator because I know I'm going to take this scale factor and multiply 6 by it, right? The less I round, the better. So if I keep that in my calculator, let me show you. Oh, iPad just, that's fine. I'll show you again. 25 divided by 4.5 gives me that big ol', I forgot the decimal. 25 divided by 4.5 gets me that big ol' 5.5 or whatever, right? Keep it in there. Times, oh, I forgot the number. 6 times 6. All right. Oh, I put an extra times. Don't extra times it. I'll push delete to get rid of the extra times. So it'll say answer times 6. That's what we want. Push equal, and you should get 33.33333, right? That's like as exact as we can get. It's fine if you're a couple of decimal points off. Obviously, I know it's going to happen. But as long as you're around 33.33, I'm happy. And right here we were doing feet for the shadow that the tree casts. So the tree itself we're going to say is feet. All right? Cool. Let's take a look at the next question. Judy's lying on the ground 45 feet from her tent. Cool. Thanks, Judy. 45 feet from her tent. Now, here's the thing. The way this picture is looking, they didn't draw separate triangles this time. I'm going to draw them as we go just to see if it makes a difference. So Judy is lying on the ground 45 feet from her tent. 45 feet from her tent. Both the top of the tent and the top of the tall cliff are in her line of sight, okay? Her tent is 10 feet tall. 10 feet tall. That's her tent. And it says that her line of sight is the top of the tent. So I'm going to connect that. So 10 feet tall. About how high is the cliff? All right. It didn't tell me in the problem how far Judy is from the base of the cliff, right? I just know there's a cliff, and I need to know how high it is. All right. And I know that Judy can see the top of it. Well, the picture tells me Judy's 45 feet from the tent. Now, the tent is 400 feet from the base of the cliff. So that means from Judy all the way to the cliff should be 445 feet, right? Awesome. So now I have two triangles to compare. The picture that they gave you, it's maybe not that obvious that we have that first triangle and that second one around it, right? So I recommend if they give you, this is called a nested triangle problem. So they give you something like this. Separate those nested triangles. Nested means to be inside of each other. So take them outside of each other. All right, this time, let's see here. I haven't done ratio yet, so let's just do ratio. I don't really care how I set it up, right? Ratios just need to be right next to each other. So I can do 445 over h or h over 445. Doesn't matter to me. I can do either way. H over 445 is what I'm going to choose. And then on the other triangle, here's where it actually matters, right? I did the height first. So on the other triangle, I do the height first. And then I did the ground second. So then I do the ground second. That's what's the most important part, that the top and the bottom match. All right, and so since these are equal to each other, I know these have to be equal to each other because they're similar triangles. I'm going to cross multiply. Those of you who forgot, anything inside those circles gets multiplied. So that's 445 times 10, which is 4,450. And 45 times h, which is just 45h. And then finally, to find height, anything next to the letter, we call that a variable, is what we're dividing by. All right, those of you who are curious why I keep showing that I'm dividing that right, 45, because 45 divided by 45 is 1. So that I have 1h. That's just h, right? That means on the left-hand side, I have 4450 divided by 45. You should get 98.88889. Let's do 2 decimals, so that's 0.89, right? There you go. You should get the same answer or about the same answer as a scale factor. All right.